Okay, welcome to Chapter 9. We are starting Chapter 9 this week, and Chapter 9 is all about data and graphs. Data is a collection of information. You can collect it with an experiment, you can collect it from a survey, things like that. So it's a collection of information. And then graphs are a way to represent that data in a neat way, and that graph can look many different ways. So this one right here is a circle graph. Circle graphs are good when you have like a set of people. 100% of people would be represented in the circle graph, and then each section would be the percent of people, or the fractional piece of people that chose different answers. Okay, so it's good to show like the relationship of the data compared to the whole, and that's why we use a whole circle for that. Okay, another kind of graph that we can use is a bar graph. Bar graphs are really good for categories. So you'll usually see like a category name underneath each bar, and the bar goes as tall as how many people maybe chose that answer, that category, or fell into that category. So bar graphs, you should be familiar with those from previous grades. And then another one is a line graph. A line graph uses line segments. These ones are really good to show data over time. So along this line, you'll see like time intervals. You might see like days of the week, or you might see different months along the bottom. And then the line plot is going to show the different values during that month, or doing it during that week, or during that day. And then the line kind of shows, is it going down? Did the data go down? Did the data go up? And it shows like trends in the data. So it's all three of these graphs are very different. All three are used for different purposes. And the point of Chapter 9 is to learn about them and to decide which graph might be best for your data. Okay. So lesson 1, 9.1 is about line plots. Line plots is another kind of graph. It looks a lot like this. It's very similar to a bar graph because it has that bottom line down here, and each one of these ticks is going to be a different category. And then instead of drawing a bar above the category, you put little X's above the category to show how many answers fell in that category. So we're going to dive into this and how to use a line plot to collect data, or to organize data. Okay, here's an example. Lots of words, I know, but that's because we have, the story problem. We have our data set. This is the data that was collected. And then we have to organize this data into our line plot. Okay, so let's see what's going on. Students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is given. Okay, so the students are doing some kind of an experiment, and they have water inside a beaker. If you don't know what a beaker is, it's like a science cup, okay? And so all of these different numbers in our data set, they represent, in one beaker, there's a fourth of a cup. In another beaker, there's another fourth of a cup. And then a third beaker has a half a cup. So each of these data sets, these data points, are different beakers and how much water is in that beaker. Okay, so if we look at our data set like this, it's kind of unorganized. They're not in order. They're just kind of like scattered all over the place. It's like the kids just wrote down some notes really quick about the water in their beaker. Well, the really good thing about graphs is it organizes our data. So the way a line plot works is you have a horizontal line, and then you have, little ticks that mark off each category. So up here in my data set, I notice that there's 1/4. There's quite a few 1/4 all over the place. Okay, there's some halves. I see a half here and a half there. And then there's some 3/4. So there's also a couple 3/4 in the data set. And then I have a little title right here. This is the amount of water. These numbers represent the amount of water in the beakers. And then to finish my graph, so this is just the beginning. To finish my graph, I need to put those little X's. So here's what I do. I'm going to start with my 1/4. Up here in my data set, I'm going to count off how many 1/4 do I have. Here's 1, 2, 3, 4, 5, 6, 7 1/4. So above the 1/4, I'm going to put 7 little X's. Ooh, almost ran out of room. 7 X's. Okay, did I get them all? It looks like I did. All right, the next number I have in my categories is 1/2. So I go back up to my data set. I have a 1/2 right here. 1, 2. So I only see 2 halves. So I'm going to put 2 x's above the half. 1, 2. And then my last category is 3/4, and the rest should be 3/4. So I have 1 3/4, 2, and 3 3/4. So 1, 2, 3 3/4. All right, there's my line plot. This is called a line plot. Okay, so that is a finished graph. That's exactly what it should look like after I organize my data into it. And then what's really great about this is I can answer some questions about my data, because when it was up here and unorganized, it's a little harder to answer some questions about it. Like, you know, if I was asked how many of a certain amount of beakers, if I was asked like this question right here, how many beakers have 1/4 cup of water? Okay, up here, I'd have to like go through each one. Okay, there's one, and I'd have to find them. Well, right here in my graph, all I have to do is count the x's above the 1/4, and I'm good. So 1, 2, 3, 4, 5, 6, 7. We have 7 beakers that have 1/4 cup of water. And there's my answer. And my graph helped me answer it really quickly because it's organized. Here's another question. How many beakers have at least 1/2 cup of water? Now here's a really interesting phrase, at least, okay? At least 1/2 cup means that it has 1/2 cup or more, okay? At least 1/2 cup means that that's the least it could be, okay? If it has 1/4 cup of water, that's not enough for this question. This says at least 1/2 cup of water. So they mean if it has 1/2 cup, it's good. But if it has more than 1/2 cup, like 3/4, then that would be good for the question too. So at least 1/2 cup is actually talking about both of these data sets. So we're going to actually count both of these categories for that question because it says at least 1/2 cup. So 1, 2 in the halves, and then 3, 4, 5 if we add in these ones for the 3/4. So there are 5 beakers with at least 1/2 cup of water. All right, so those questions were easy. Let's look at a little more difficult question. This question, it involves a lot of math, but it's math that we know how to do because we have been working on fractions a lot in Chapter 8. So this one is asking for the average amount of water in the beakers. And you're going to have to think back to 4th grade what average means. Okay, average is something we do with data sets. It's when we find like the mean. Okay, mean is the average. So your 4th grade teacher might have called it the mean. Your 4th grade teacher might have called it the average. But when we find the average of a data set, what we do is we add up all of the numbers in the data set. So we're going to have to add up 1/4 plus 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 1/2 plus 1/2 plus 3/4 plus 3/4 plus 3/4. We're going to have to add all of these fractions up. You could even look back up at the data set. You could add all of these up. So we got to add them. And then after we add them, we need to then divide that sum. It's going to be a bigger number after we add them all up. We're going to divide that sum, the answer that we got, by how many beakers the experiment had. So if we count how many x's we have, I think there was 12. There's 3, 5, and 7. So there's 12 beakers. So first step is add it all up. Okay, we've got to add 1/4 plus 1/4 plus 1/4. So let's do this, just this category first. So 1, 2, 3, 4, 5, 6, 7. There's 7 1/4, right? So what I'm going to do, I'm going to use a different color because this is just my side notes. I'm going to do 7 times 1/4, right? And 7 times 1/4, remember we pretend there's a 1 under the 7. There's Stan. And then we multiply across. So 7/4. So this is the sum for this category, but we also have to get these two, right? So I'm going to put down here 7/4. That's my first sum. Plus, now we got to get this sum right here. This one's kind of easy. It's 1/2 plus 1/2. What's 1/2 plus 1/2? It's a whole, right? It's 2 halves. I'm going to write it. Okay, so we know that this is 1 whole. So this is like 2/2, or just one big fat 1. But I need a whole, and I need to add it to fourths. Okay, so remember, to add fractions, we need a common denominator. So I don't think I'm going to write 1. I think I'm going to write 4 over 4. Okay, 4 over 4 is 1, right? 2 over 2 is 1. Okay, either way, I'm adding 1. I just represented it a different way so that it has this common denominator for me. Okie doke. Our last category we need to add together, so we're still adding all these together, is 3 of the 3/4. So we're going to do 3 times 3/4, and it's getting all scrunchy in here. 3 times 3, oh, sorry, we have to put the 1. 3 times 3 is 9, and fourths. So we got fourths again, so that's good. And I'm going to add that down here, 9/4. So here's the three category sums, and then I need to add these all together. So since they're all fourths, that's really good. That means my denominator is going to be fourths. And then I got to add these numerators. So 7 plus 4 is 11. 8, 9, 10, 11. Plus 9 is 20. So I got 20/4. Good. Okay. 20/4 is improper. I need to do in and out, or I need to divide to find out how many wholes is in there. And 4 goes into 20 exactly 5 times. So my answer is 5 wholes. That means that 5 whole cups of water, if I added all of these cups of water together, I've got 5 whole cups of water. Okay, that still doesn't answer my question. The question is asking for the average, and there's 2 steps to the average. The first step is to add everything up and see how much you got, and I got 5. And then step 2 is to take this sum. We're going to take 5, and we're going to divide it by how many beakers I had to add together. So I added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 beakers together, and so I'm going to divide by 12. Okay, 5 divided by 12. I can't put 12 into 5. 12 doesn't go into 5 at all. So this is that type of division problem where, since we can't really divide 12 into 5, we're just going to rewrite this division problem as a fraction. Because remember, that fraction bar is a division sign. So we're going to write 5 divided by, 12, just like that. Okay, because that fraction bar is a division sign. 5/12 is my average. This is the average that this question was asking for. So that tough question did have a lot of steps. We had to add each category up, kind of take how many in each category, times it by the amount for that category, get these numbers, add them together, find the sum, and then the last step was divide it by how many of those beakers we had to find the sum in. So my answer is 5/12 for the average. All right, let's do another example of a line plot. And this will be our last example for this lesson. So it's a lot the same. Here's our story problem. A girl is making a necklace using different sized beads. The sizes of the beads are given. All right, and here's our data set. So she's got all these beads of different sizes, different weights. Okay, and we got some 2/5 in there, we got some 4/5, we got 1/5 and 3/5. So when I set up my line plot, I'm going to have a horizontal line, and then I'm going to have categories underneath. So I have 1/5 because I saw some 1/5s up there, 2/5 because I saw some 2/5, 3/5 and 4/5. I didn't see any 5/5, and I didn't see anything other than fifths. So these are all my categories. And then here's my title. These numbers stand for the mass of the beads, or I should have put size of the beads. I'm thinking of our science lesson, how mass is kind of like how much of an amount of matter there is. So it is kind of the mass too. So all right, now we're going to take our data set and we're going to put it into our line plot. So the first step is to look at category 1/5. And so we go up here and we have to find how many 1/5s we got. Here's 1, here's 2, 3, and I think that's it. So I see 3 of the 1/5, so I'm going to put 3 X's above 1/5. All right, next category is 2/5. I'm going to find all of those. Here's 1, 2, 3, 4, 5 of the 2/5. So I'm going to put 5 X's above that. All right. 3/5. I got one here. 1, 2, 3, and I think that's it. 3 of the 3/5, 3, and then 4/5. 1, 2, 2. Okay, something I do sometimes just to make sure I got them all, I'm going to count how many are up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so then I should have 13 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I think I got them all. So there is my line plot. And now that I have my line plot made, I can answer all kinds of questions. So I could answer, how many more 2/5 size beads does she have compared to the 4/5 size beads? So remember, how many more is a subtraction problem. They want to know how many on top of these two are there in the 2/5. So if 2/5 has 5 and 4/5 has 2, we would subtract 5 minus 2, and then my answer to that question would be 3, right? Okay, I could ask how many are at most 2/5 in size, or 2/5 grams in size. So at most is kind of the opposite of that question from the other problem. At most means that the most it could be is 2/5. So 2/5 and under, okay? So I would count all of the 2/5, and then I would also count the 1/5 in that answer also. So I would have 8 beads that are at most 2/5 grams, okay? So lots of questions can be asked and answered because it's now organized. It's a lot easier to find our answers. We're going to do another one of the average questions, okay, because we need to remember the average from 4th grade, and we need to, be able to do that kind of math. So we want to find the average mass of the beads, okay, and if you remember my steps from earlier, I have to add up all of those numbers. All of those fractional beads have to be added together. And you know what? I'm really lucky because they're all common denominators already. They're all 5ths. So this one might be a little easier than the first one. All right, so in the first category, I have 3 of the 1/5. So I'm going to do 3 times 1/5, right? And that is 3/5. So I'm going to bring that number down here, 3/5. Okay. In the 2/5 category, I've got 1, 2, 3, 4, 5. So I'm going to times this by 5 over 1. All right, and I get 10/5. I know that 10/5 is 2 wholes, but I'm not going to write that yet. I'm going to just bring over here 10/5, and I can add it because it has common denominator, right? Okay, my next category, I have 3 of the 3/5, so I'm going to times this by 3. It's getting really crunchy in here. Hold on, let me draw some lines so you can see my differences. There we go. Okay, 3 wholes times 3/5, because there's 3 of them, and that's going to be 9/5. Okay, bring 9/5 over here. And then the last one, I have 2 of the 4/5 size beads, so we're going to times this by 2, and we get 8/5. All right. So almost done with the adding together. I just did the categories so far. Now I have to add these categories up. So since the bottom is all 5ths, my answer is going to be also 5ths. And then I need to add the numerators. So 3 plus 10 is 13, plus 9 is 22, and then plus 8 more is 30. So I have 30/5. Okay, that is improper. I need to do in and out. I need to divide to see how many wholes that is. And 5 goes into 30 exactly 6 times. So I have 6 grams of beads. When I add them all together, it's 6 grams of beads. Okay, I'm not done. Average. The first step is to add it all together. I've only done the first step so far. And then the second step is to take that sum. So I'm going to take 6. And I'm going to divide it by how many beads I had in my data set. So remember when I counted them all, I had 13 beads. So I'm going to divide 6 divided by 13. Again, we have one of those division problems where 13 does not go into 6. Okay, so we're going to just write this as a new division problem as a fraction, 6 over 13. And this is our answer. It would also be in grams. Okay, so the average weight or the average mass of the beads is 6/13 of a gram. And that is my answer. All right, guys, so that is lesson 9.1, line plots. Line plots look like this. It organizes our data by categories with little X's on top, and we can answer all kinds of questions with it. All right, thank you, guys.